As we learned in the quantum mechanical model the other day, the atom is quantized, which means there are principal energy levels within the atom. And remember, this is the quantum mechanical model of the atom, not the Bohr model. So in the quantum mechanical model of the atom, we have principal energy levels, which we call n, and every principal energy level has n sublevels. Now we call those sublevels n, followed by the letters S, P, D, and F, like this. So n equals 1 has one sublevel that we call 1s. n equals 2 has two sublevels, 2s and 2p. n equals 3 has three sublevels, 3s, 3p, 3d. n equals 4 has 4, 4s, 4p, 4d, and 4f. 5 has 5, 5s, 5p, 5d, 5f. And if you've been following along, you know we've run out of letters. It doesn't really matter, but we can use the letters G, H, and I if we wish. 6s, 6p, 6d, 6f, 6G, and 6H, and then 7, 7S, 7P, 7D, 7F, 7G, 7H, 7I. And the reason it doesn't matter that we run out of letters is right now we don't have any elements that have this many electrons, and you'll see what I mean in a minute. So these are the sublevels, and energy increases in this direction and also in this direction. But the problem we have is that the energies of some of the sublevels in consecutive principal energy levels overlaps. And so we end up with an order of increasing energy that looks like this. So if we draw diagonal lines through our picture, we get an order of increasing energy that follows the arrows. So the lowest energy sublevel is 1s, and then if we go back to the top, then 2s, back to the top, 2p3s, then 3p4s, 3d4p5s, etc. And that gives us the order of increasing energy of the sublevels. Now remember, the electrons that are in those particular sublevels will have that certain amount of energy. And so the lines on the line spectra that we see come from transitions between different orbitals of different energies. I just used the word orbital there, so let's make sure we remember what that means. Orbitals are probability regions in space where we may find an electron with a given amount of energy. And different types of sublevels, S, P, and D and F, have different numbers of orbitals. So if we go S, P, D, and F in that order, we'll see that the number of orbitals, O for orbitals, that those sublevels have are 1, 3, 5, and 7 in that order. Okay, so my little trick is orbitals are odd. The number of orbitals in each type of sublevel are the odd numbers in the order 1, 3, 5, and 7. Now, each orbital can contain 0 or 1 or 2 electrons. So the maximum number of electrons per sublevel is 2, 6, 10, and 14. And we get those numbers by multiplying the number of orbitals by 2. Right? So 1 times 2 is 2, 3 times 2 is 6, etc. So our trick for that particular column is EE. Electrons are even. Okay, so remember OO, orbitals are odd, EE, electrons are even. And this information is very important when we come to write electron configuration. So electron configuration is assigning electrons to the lowest energy sublevel first, and then when it's full, we move on to the next one. So what you have to remember is that the maximum number of electrons in an S will be 2, in a P will be 6, in a D will be 10, in an F will be 14. So this is the column here that's going to be really important when we come to do electron configuration, and we'll do that in the next video.